14. Showing disjunctions using indirect derivation. The second form of ID is very useful for showing atomic formulas, as demonstrated in the previous section. It is also useful for showing disjunctions. Consider the following derivation problem. 1 PQ/2 PQ. We are asked to show a disjunction PQCD is not available because this formula is not a conditional. ID of the first form is not available because it is not a negation. DD is available but it does not work except in conjunction with the double negation maneuver. That leaves the second form of ID, which yields the following. 1 PQ/2 PQ and 3 PQS4 DD5? At this point, we are nearly stuck. We don't have the minor premise to deal with line 1, and we have no rule for dealing with line 3. So, what do? We can always write down a show line of our own choosing, so we choose to write down P. This produces the following part derivation. 1 PQ/2 PQ and 3 PQS4 DD5 P and 6 PS7 DD8 PQ6, I9 3, 8, I10? We are still not finished, but now we have shown P, so we can use it while it is still available. This enables us to complete the derivation as follows. 1 PQ/2 PQ and 3 PQS4 DD5 P and 6 PS7 DD8 PQ6, I9 3, 8, I10 Q1, 5, O11 PQ10, I12 3, 11, I lines 5-9 constitute a crucial, but completely routine, sub-derivation. Given how important, and yet how routine, this sub-derivation is, we now add a further inference rule to our list. System SL is already complete as it stands, so we don't require this new rule. Adding it to System SL decreases its elegance. We add it purely for the sake of convenience. The new rule is called tilde-wedge-adl. As its name suggests, it is a rule for breaking down formulas that are negations of disjunctions. It is pictorially presented as follows. tilde-wedge-out-OAB. AB is with all inference rules, this rule applies exclusively to lines, not to parts of lines. In other words, the official formulation of the rule goes as follows. tilde-wedge-out-O if one has available a line of the form AB, then one is entitled to write down both A and B. Once we have the new rule O, the above derivation is much simpler. Example 1 PQ/2 PQ and 3 PQS4 DD5 pages 3, 06 Q3, 07 Q1, 5, 08 6, 7. In the above problem, we show a disjunction using the second form of indirect derivation. This involves a general strategy for showing any disjunction, formulated as follows. General strategy for showing disjunctions: if you have a show line of the form AB, then use indirect derivation. First assume AB, then write down then apply O to obtain A and B, then proceed from there. In cartoon form AB at ABS. OBO. This particular strategy actually applies to any disjunction, simple or complex. In the previous example, the disjunction is simple, its disjuncts are atomic. In the next example, the disjunction is complex, its disjuncts are not atomic. Example 2 1 PQ and QPR2 P and Q and 3 P and QS4 DD5 P and Q3, 06 P and Q3, 07 PQ1, 5, 08 pages 7, 09 Q7, 010 P and Q8, 9, and I11 6, 10. The basic strategy is exactly like the previous problem. The only difference is that the formulas are more complex.